Okay, so on the U-try, we now know that the side squared compared to the side squared ratio is equal to the area to area ratio. So if we're looking at our first figure, a smaller figure, we know that 7 squared over 15 for the side length squared would be equal to the area 84 over the area of the big one. We'll call that x actually. And then from there, we just cross multiply and solve. So actually, before I cross multiply, I'm going to go ahead and square those. 7 squared we know is 49. 15 squared we know is 225 equals 84 over x. And now I'm going to cross multiply. So 84 over 225 gives us 18,900. And x times 49 is 49x. So we can equal those cross products to each other, and now we have an equation where we can solve for x. So to get x by itself, we're going to divide both sides by 49, and that gives us 300. That cancels out, and we get approximately 385.7. Did it say what to round to? To the nearest whole number. I didn't round the last one either. So that one, what should have been just 115, and this will be 386 to the nearest whole number. Okay, let's look at another example. In example 3, it says find the similarity ratio. That's one thing we have to do. Similarity ratio. And number 2, the ratio of the perimeters for each pair of similar figures. So let's see what we're given. What we're given is that we have 2 regular hexagons. So we know a hexagon kind of looks like this, and maybe another one that looks like this. And we know that the sides, the areas are 8 and 32. We don't know the side lengths. Okay, so we're going to have to work backwards then, because what we do know, remember with me, at this point we know that side to side squared equals the area to the area. So we know this part of the equation. We know, I like to put the smaller number on top, so I'm going to say 8 to 32 for my area ratio. What I don't know is what side to side equals. I only know what side to side squared equals. So if we're going to work backwards, if we're going to get rid of the squares in order to figure out what the side ratio is, we need to do the opposite of square. We need to square root. That's going to cancel out those squares. So how this works, so this is the side to side ratio now that those squares are canceled out. And the easiest way to work this is to actually reduce 8 to 32 first. So 8 goes into 32 4 times, so this is a 1 to 4 ratio. The other thing I'm going to do here to make this easier on us is the square root of an entire fraction is the same thing as the square root of the numerator and denominator separately. And so the square root of 1, what number times itself is 1? Well, that would be 1. And the what number times itself is 4? What's the square root of 4? That would be 2. So the similarity ratio, the side to side ratio, is 1 to 2. That's our first answer. We'll call that number 1. Now here comes the fun part. For the ratio of the perimeters for part 2, you don't have to do anything. There's no calculations, because remember, friends, that the perimeter ratio is always the exact same as the similarity ratio. So these are always the same. So we have found our perimeter ratio as well. Okay, so you have a U-try over here. I know this is kind of tricky working backwards business. Give it your best shot and come back and check the video and see how you did. Go ahead and pause the video is what I mean. Okay, so you had two squares with an area of 81 and 25, and so that was their area, the amount on the inside. And we now know that the side-to-side ratio squared is the same as the area-to-area ratio. So I filled in our areas part of this formula, and so now I'm going to work backwards to figure out what the original side-to-side ratio was. So I'm going to do the opposite of squaring. I'm going to square root, and we know that squares and square roots cancel out. And so this becomes just the side-to-side ratio equals, this one doesn't reduce. 81 over 25 do not have any common factors. So I'm just going to split it up into the square root of 81 and the square root of 25 separately. So what number times itself is 81? That would be 9. What number times itself is 25? That would be 5. So our side-to-side ratio, our similarity ratio is 9:5. But remember, that was only one of the two things we were supposed to find for this problem. We were also supposed to find the ratio of the perimeters. But we said the perimeter to perimeter ratio will always be the exact same. So it is also 9:5.